All right, in the last video we talked about case 1 when the denominator is larger than the numerator. So that was case 1. Case 2, we'll say where the denominator has a smaller degree. So this is 4x to the first, and that's x to the second. So obviously the highest degree in the denominator is smaller than the numerator. And in this case, you don't actually get a horizontal asymptote. You get something called an oblique asymptote. Another way of saying oblique is a slanted asymptote. And I will show you what that looks like in just a sec. But let's go through our same steps as before. We'll start by factoring. And again, we want to swap those. We want to reverse those. So what multiplies to -4 and adds to +3? That's going to be +4 and -1. Okay, and then on the bottom, this has a 4 in common right here. So we can take out the 4 and we'll have x plus 1. So we've got the factors. Let's get the asymptotes and the holes. So first of all, there's actually not going to be any holes here because on the last problem we were able to cancel something on the bottom with something on the top. This x plus 1, there is no x plus 1 on the top. There's an x minus 1, but that's not the same, so we can't cancel. So there are actually no holes right here of any kind. There will be a vertical asymptote. It's what's going to make that equal 0. And the answer is x equals -1 is going to make that 0. So let's put our vertical asymptote on this graph. Since there's only one vertical asymptote, that means there's going to be two regions to the graph, one to the left of that and one to the right of that. Okay, then the horizontal asymptote, we said there isn't going to be one. There's going to be a slanted or an oblique asymptote. The way you find this is by using long division, and it's been a while since we did that. So let's recall how that's done. We'll take 4x plus 4 and we will divide it into this right here. Okay, so this first thing we need to say, how many times does 4x go into x squared? Or another way of saying that is, what is x squared divided by 4x? One of those x's cancel, and that one cancels. So we're left with x over 4, or we're left with 1/4 x. Okay, then after that, we would multiply 1/4 x times 4x, and that would give us x squared. 1/4 x times 4 would be just 1x. We'll subtract those, and 3x minus x is 2x. Bring down this minus 4. How many times does 4x go into 2x? Or what's 2x divided by 4x? And this reduces down to 1/2. So we'll have 1/4 x plus 1/2. Half times 4x is 2x. Half times 4 is 2. And then -4 minus 2 gives us a remainder of -6. Over what we divided by. Now here's the thing, when we actually graph this, we're really not going to be concerned with the remainder, and here's why. Remember that the horizontal asymptote occurs as x goes to infinity, and as x goes to infinity, this thing, you're going to have 6 over infinity, and that's practically 0. So we'll say that our horizontal asymptote here, really our slant asymptote, is this line right here. So in other words, it's not just a straight horizontal line, that's actually like an mx plus b type of line. So I'm just going to erase this, and then we'll graph that line so we can see what it looks like. And I'm going to change that from horizontal asymptote to, I should really say, oblique asymptote. So how do you graph 1/4 x plus 1/2? Well, 1/2 is the y-intercept, that's right there. And then we go up 1 over 4, up 1 over 4, and let's go the other way too. We'll go down 1 to the left 4, down 1 to the left 4. So now we just need to make a line right here, dotted line, because that signifies the asymptote. So when we actually graph this, it's not going to have a horizontal asymptote, it's going to have that red line as its asymptote. So we've taken care of asymptotes, there are no holes. Now let's find the intercepts. So the x-intercepts occur when y equals 0, and the y-intercepts occur when x equals 0. So let's start with x equals 0. That's a little bit easier. If you plug in 0 for x here and here, the top would be -4, and the bottom would be +4. So that equals -1 for y. So we're going to have the point 0, comma, -1, and that's going to put us right here. Okay, then the y-intercepts, well, we need this thing right here. This is our factored equation. We need this thing to equal 0. There's no way for that to happen on the bottom. There's two ways for that to happen on the top. If x equals 1, we would get 0 in that parentheses. If x equals -4, we would get 0 in that parentheses. So -4, 0 is right here, and 1, 0 is going to put us right here. Okay, Now we can connect the dots on these. So the only way for this to respect the vertical asymptote is for it to go down right here. It would not be possible to have that go up. And the only way for it to respect that asymptote is for it to go in that direction right there. So there's our first part of the graph. Last thing is draw the graph. We've pretty much done that. We just need one more value on the left region. That's on this region over here. We have one point. We want another point that's between -4 and this asymptote right here at -1. So let's just pick -2. And if we plug in -2 for x all along here, we'd have -2 plus 4 is +2. Right here, -2 minus 1 is -3. On the bottom, we're going to have 4 times -2 plus 1 is -1. So this becomes -6 over -4, which reduces to 3 over 2. So that means we're going to have a point at x equals -2, y equals 3 over 2, or 1.5, which is here. Now we can see that this is going to go up this way, and it's going to go down that way. So that is what our graph looks like in a case 2 example when we have an oblique or a slanted asymptote.